Alright, as you can clearly see by the title screen, me and my pal SpongeBob are going to be working through some square root reminders with you. I just want to recap some things that you should already have in your background knowledge about square roots so we can move into the more difficult stuff later on. Quick reminder that a square root is of a number n is a number m such that m squared equals n. Your basic idea is, well, the square root of 9 is 3 to you guys because 3 times 3 is 9. However, that is not the only square root of 9, which we'll talk about right here. Every positive number has two square roots actually, one positive and one negative. Notice every positive number has two square roots, one positive and one negative. Ask yourself, what's the square root of a negative number? What's the square root of -1? We've actually talked about that a little bit in class already. The radical sign means the square root of the number under the radical. So if I have that radical and then I have a 9 underneath it, I'm asking you for the square roots. Now you know that the square root of 9 is not just 3, but it's also -3. Because mathematicians are lazy and we like shortcuts, we have a way to actually show that quicker, the plus minus symbol, plus or minus. So if I asked for the square root of 9, you could tell me that that is plus or minus 3 because it's a positive 3 or a -3. I'll give you another example of that. The square root of 100 is plus or minus 10 because 10 squared and -10 squared, notice the parentheses, each equal 100. Notice 0 has just one square root because 0 squared equals 0. It's the only one that doesn't have two square roots because it's not a positive number. And again, think to yourself, the square root of a negative number, are we going to talk about that much here in class? Find the square roots of the numbers. So this is, again, just asking you, what two numbers do I have that when I multiply by itself, I get that number? A lot of you guys know that 5 times 5 is 25. Well, now it's then simple to think the other one is a -5 times a -5. Those same signs give you a positive number. So my answer here would be plus or minus 5. You also see the square root of 64 would be plus or minus 8, and the square root of 144 would be plus or minus 12. I think that should all be pretty quickly in our background knowledge. We're talking about perfect squares there. 25, 64, and 144 are examples of perfect squares since they are squares of an integer. Because they work out nice and neat and even, we call them perfect squares. The easiest way to think about this, if I ask you the square root of 9, you know it. If I ask you the square root of 10, you hesitate. 10 is not a perfect square where 9 is. To give you one more example, picture squares to help visualize this idea. What are the first perfect squares? I'm actually going to picture that these squares, I'm going to find their area and I'm going to give them dimensions. This square, the first perfect square, would have to be used using 1. And so 1 squared to find this area would be 1. My next square then would have side lengths of 2. So 2 squared, 2 times 2 gives me 4. My next side lengths, you should start to see the pattern here, would be 3 and 3. 3 squared to find that area gives me 9. And my last perfect square would be 16. So when I ask you what are the first 4 perfect squares, you tell me 1, 4, 9, and 16 because they are squares of an integer number. However, they're not always going to be that way. We're not always going to deal with perfect squares. You can use perfect squares to approximate square roots of a number that isn't a perfect square. For example, I have the square root of 66 and I want it to the nearest integer I want to approximate. I will use perfect squares on either side of 66. So I picture 66 on the number line. The perfect square that is less than 66 happens to be 64. That is 8 squared to give me 64. The perfect square to the right of it then, if 8 squared gives me 64, 9 squared gives me 81. I know that the square root of 64 is 8 and the square root of 81 is 9, and I'm asking myself, which one is 66 closer to? And I think it's rather clear that it's closer to 64. So if we were approximating or estimating, we would say the square root of 66 would be about 8. I'll give you another example of that. I approximate the square root of 125 to the nearest integer, copy it down, pause it, try it on your own. Then think to myself, all right, I'm looking at 125 and I need perfect squares above and below. Below 125, the perfect square would be 121. That's 11 squared, or -11 squared. And when I see 125 then above, 12 squared gives me 144. And again, I see, well, which one is it closer to? Is it closer to the 121 or is it closer to the 144? If it gets really close to in the middle, do some subtraction and find the difference. But I should see that this will be about 11. Now, I know you're asking yourself, I thought we said they have 2 square roots, and they absolutely do. It's going to be a trick for you guys to realize. When I give you something like x squared equals 25, and I want you to solve for that, we'll still use inverse operations and we'll find the square root. In this case, because we're solving for an unknown, x could be either positive or -5, and we don't know that, so we'll leave it as that. When we look at some evaluating expressions and we look at some approximating for certain values, we usually just assume it to be positive. Big key there. Here would be where you would see that again. If I evaluate the radical expression when a equals 11 and b equals 5, again, we should be thinking to use substitution here. I rewrite the problem exactly as I see it. Every time I substitute, what do I have to put around that number? And then I'm going to just work it out using the order of operations and different things like that. I see the radicals also are referred to as exponents. We treat radicals like exponents. So I got to take care of this radical, but I have to take care of what's inside the radical first. And if I have 11 plus 5 squared, the first thing I need to do is square that 5. So I now have 2 times the square root of 11 plus 25. I can add that up, and I have 2 times the square root of 36. And again, yes, 36 has 2 square roots, 6 or negative 6. But when we're evaluating, we can assume the positive and take 2 times 6, which gives us an answer of 12. Very quick review of square roots and how to work through them. Hopefully SpongeBob and I did you a lot of favors, and you'll be ready to go for class on Tuesday.